Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 23, we will talk about we are covering the third part of data access and manipulation. So the different concepts that we will cover will be on direct connection with databases using database connectors, and then we will demonstrate that in case of SQL, MySQL. Then direct connection with we will do the same with Postgres, PostgRE SQL using also database connectors. Then we will talk about direct connection using this ORM framework, and finally we are giving you a demonstration of how using SQL Alchemy we can also connect with database following this ORM framework structure. So already we have discussed this in earlier lectures that we have different kinds of databases: relational databases, NoSQL databases. Like relational databases are SQL based mostly, like SQLite, MySQL, Postgres SQL, SQL Server. Then NoSQL databases are like MongoDB, Firebase, Redis. So how to store data in those we have shown you earlier, right? So we have discussed this. Now Python also supports access to all these kinds of database, right? But for each database there is a specific program or a driver is required to connect to which is required to establish a connection. And once you establish a connection, as we did in SQLite in the earlier lecture, we can after establishing a connection we can go and do insert, update with more or less which is similar to what we did earlier. So little bit here and there some changes could be there, but basic structure and the fundamentals are same. For example, you can see first you have to install the required database connector for whichever database you are connecting. Establish a connection to the database, that's the first step. Then create a cursor object to execute SQL queries that we have learned that this cursor object is the one which actually executes the queries inside the database. Then execute SQL statements like select, insert, update, delete, all these things we can do. And then we can fetch the results. And once we fetch the results, it could be part or if that statement actually is returning something. If it is update, there is no fetching of result, but if it is select star, it will fetch results. And then commits the changes, and then finally once we are done with it, close the cursor and the connection. So that's the basic standard way to access a database. So first what we have to do is we have to assuming that you are using Spider for your practices. Spider of course runs within the Conda environment, Anaconda, and so we have to install the these packages like this connection packages within this Anaconda, right? So but because it is we cannot do it directly in Spider, so sometimes there are some problems happen. So what you do is you open the Anaconda prompt. So you go to your search or open programs, you will find Anaconda prompt there along with Anaconda Navigator, Anaconda PowerShell, all these things are there. So you open Anaconda prompt and you install packages using this Anaconda prompt, right? So you can give either the command conda install MySQL connector Python or conda install scicop g2 based on which database you are using, or you can also use the earlier command that we gave, that is pip install MySQL connector Python or pip install scicop g2 library dash binary. So this could be the commands that you can give, and once you give those commands you will see this kind of screens. So I have also run those and I have pasted those for you. So in the first one over here I have given this conda prompt, conda install MySQL connector, this one, and for the scicop g2 we have installed it using the pip command. So both the commands are given, and you will see that after that it will load those particular libraries and then they will make it part of the package. So how do I establish this connection in MySQL? More or less it is same as what we did in SQLite, only difference being we have to specify the connection properly, right? So over here, the first statement is import mysql.connector, which imports the connector, and then there is con equal to mysql.connector.connect. So this is used to connect to the MySQL database, and what we have to do is we have to put in the host name, the username, the password, and any other kinds of parameters like what is the name of the database that you want to access and so on, in this case which is household survey, right? So in your username password is your access whatever you have configured the database with, right? So if the database doesn't have your username password, you would not be allowed, right? Similarly, if it is in the local host, means it's in your same machine, but if it is not in the local host, if it is in a remote machine, you have to give that particular pathway. So for example, localhost refers to the local computer or the server where MySQL is running, and so in this case localhost, basically its IP address would be 127.0.0.1, which is standard, and it indicates that the server is a local computer. And so moral but if you really want to access a database which is in some other computer, it's in a remote, it's a remote server, right? So in that case, you have to give the proper IP address or the host names of that particular remote server, and then actually you have to give those proper parameters, and then only you can establish a connection. So over here you can see host equal to 192.168.1.100. So this is the remote server's IP address, and then you again give your username, your password, and then the database you want to access. Now if you are able to access the database also depends on if that permissions have been given to this particular users, like grant, revoke, we have done earlier in SQL. So those has to be also given in this case. So I will show you those things. So once you establish the connection, that is cursor equal to, then you can execute the commands by bringing in the cursor command, right? So cursor equal to con.cursor and then cursor.execute. This is the value. The only difference over here you see is that so it is again creating the table household survey if it is not existing, and here I am here auto increment column is introduced, which is made into the primary key, unlike the ID key which was made the primary key in the last case. So household ID is a varchar over here, it's not made into a primary key. So this auto increment is actually in SQL we can automatically we put a serial number 1, 2, 3 and it's auto incremented, right? And because it is auto incremented and all, it could be made the primary key. So to avoid any further confusion regarding what should be set as a primary key and so on. So number of people is integer, number of household income is int, housing type is varchar. So this is the data types have been specified, and then once we have specified the this, we have created the table with this particular schema. Then I'm first storing the data that needs to be input in this data to insert list, right? So over here you can see that this is again we are storing, these are the data sets that are being stored, that would get stored. So same way we did earlier, cursor.execute many, and over here we are using the percentage sign, which is like the placeholder, and the value that I have to insert is data to insert, which is already stored in the previous over here. So this will get inserted and it will insert into the household survey this thing table, and this will then using con.commit I am saving the transaction, and finally I can print the data, and for that we have to execute a select star statement, select star from household survey, and then cursor.fetch all will fetch all the data, and then I can print that data, and this is being stored in rows like earlier, and I can print that by again running a loop where for row in rows I can print that particular row. So finally once we have done, then we close the cursor and then we close the connection. So this is how the overall statements are same. It will be almost same in PostgreSQL as well. Now what you must ensure is before you are running the program, the database has to be set up, of course, That means if the database is not set up and you are accessing that, then it will create some problem. So log into your MySQL server. You have to first type in the root name, those passwords and all these things. So you type in this command, or we have taught you earlier how to do that. And when we have taught you this particular MySQL database, we have given demos of that earlier. So you create a database. If it is not created, then create database household survey and grant permissions. It is optional. If you need access for specific users, you want to give specific access, you can give grant all privileges on household survey. Start to that username at the @localhost from where you are. This person is located in the local host. That's why it's given. But if I can also specify IP address, that means I can specify from where this data would be accessed, right? And also your password also has to be given. So if I can only allow a list of specific IPs which would be allowed, that also could be given, done. So now that we have to open that particular database, then only we can run these programs. But you have to understand, sometimes the database is not in my local host, right? It could be in a remote server. So in that case, that particular database where the remote server is, we have to allow remote access to MySQL or PostgreSQL database, and for that we have to make some changes to the server configuration files. That means wherever you have stored the database, there you have to make some changes so that a Python program from another computer can access it. Now, how do I do that? Usually you have to update your MySQL configuration. This file is there, which is basically stores the information about how SQL is configured in that particular remote machine, right, on that particular server. So usually that would be a file called my.cnf or my.ini, which is usually located in this particular directory. So like for example, you can find it in Windows c.program data MySQL server in this way. And once you find that, you open that particular ini file in the notepad, and within that file you will find this kind of statements given there, right? That means, but you have to now change those. Now so what you do is look for the bind address directive and change it to 127.0.0.1, which is localhost, which initially is set as localhost. That means people from the localhost can access that server, but to 000 or the IP address of the server to allow remote connection. So that means if I give 000, anybody can be able to access this. But if I want to limit that, I have to give specific IDs like this. That means only people from this IP address can access this particular server, right? So that also we can specify. So what it basically means is, this binding address means by default it is the localhost. I am going to change this to this. So I go into the ini file and open it in the notepad, change this value to this. That means my configuration is changed. So now anybody can access this particular server or this database which is located in this server. So then again, log into MySQL, the same way MySQL, you have to give the root values and all. Then allow your MySQL user to connect from any host, grant all privileges on household survey, start to whatever is the username, and this percentage sign actually makes sure that that means that anybody can access, or it could be a specific, it could be replaced with this particular specific ID if you want to specify from which computer this person can access. Now you have to also check the firewall settings as well. That means so that this connection with the Python program is allowed. So for that, usually this port number of a computer is 3306 for MySQL, and this has to be opened in your firewall, right? And same for Linux server also, we can use this. So these are a little bit advanced things, but I think once you install the server in a remote server, you are developing a program, you are trying to connect, if you follow this more or less with some tweaking and all, you would be able to adjust and establish a connection using your Python program with a remote database. So showing you the same thing like direct connection with PostgreSQL using database connectors. So just to repeat, there is not too much difference. Only thing is you have to again open the PostgreSQL server, and this is how you open that. You type in PSQL -u Postgres, and then create a database. If it is not there, create database household survey, then grant permission, It is optional, but grant all privileges on database household survey to particular username that will make sure that this particular person will be able to access the database. Now, we established a database like con equal to psych of g2.connect, database name, username, password, the host, is it localhost, then the port number, these are all specified over here. Port number for this Postgres is 5432, whereas in the MySQL it was 5306, right. So, then we can establish this cursor con.cursor and cursor.execute will actually execute the queries. Same way we are execute the create table, then we are storing the data in data to insert, and finally we are executing the cursor.execute menu will insert all this data which is there in data to insert row by row into this particular household survey table in each of these particular columns. And then we can save the data, that is con.commit, and we can print the data, and then we can execute that star command, select star from household survey, and using fetch all I can fetch all this and store in rows. Then I can print the rows one by one using a loop. And finally, once we are done, same as earlier, we close the connection, close the cursor, and then we close the connection. So, this is how we using database connectors we can connect with any database, right. Now, in addition to database connectors, we can also connect with database using this ORM framework. So, we have discussed this earlier in little bit, we have done it in details, but now we will really look into the code, how to write the code for that. So, frameworks such as SQL Alchemy provides an abstraction layer allowing to interact with database using Python classes and objects instead of raw SQL queries. So, what it does is it maps objects to the tables, right. So, that means objects are what? Objects are instances of classes, right. So, these classes are from Python. So, we will map the table with the object. So, ORMs maps database tables to programming language objects classes. Each row in a table corresponds to instance of that particular class. And then CRUD operations are supported, that means create, read, update, delete, all these operations could be done without writing SQL, but writing some functions of that particular class by calling some function of that class. And then many ORMs allow developers to construct queries using method chaining or queries or query DSLs instead of raw SQL. Now, what it means is that means you want to select, then based on a certain condition, then you want to do some join. So, you can give a series of call a series of functions, and you can combine this function so that it almost acts as a query or a complicated query. So, that is what could be done in ORM frameworks and all. And then the database abstraction happens, that is ORMs can work with multiple databases like MySQL, Postgres, SQLite and all. So, you do not need to have separate connectors and all these things. So, through SQL ORM itself you will connect to any database, right. So, the amount of configuration changes would be much limited. So, again how will I go ahead? First I have to define the models, that is create a class that represents a database table, that is the first thing. Then connect to the database, establish a connection using ORM, any database, any connection is to be established, and then I have to perform the queries by using ORM methods like to insert, retrieve, update or delete. So, that means I can call ORM functions or methods, and automatically I can do all the tasks that we were doing earlier by writing or executing queries and all. So, the first thing you have to do for the demo is, of course, or for testing, for practicing, is to install SQL Alchemy and the database driver for MySQL, SQLite or PostgreSQL, whichever you are installing, you can do that. So, pip install SQL Alchemy and MySQL connector Python. So, in this case, we are using these two together, right. Now, over here we have used SQLite, I guess, but we can always use MySQL as well. So, anything could be accessed. For SQLite, you do not need to install anything because it is already inbuilt, right. So, first what we do in this particular program is from SQL Alchemy import create engine, column, integer, string. These are the different, or classes that we can import, or different modules that we can import, right? So this create engine is there, and then column, integer, these are all separate classes or modules which has to be imported. And then SQL from SQL alchemy .ext.declarative import declarative base. Now this is the base. First I have to so this is the first part, and then from SQL alchemy.orm import session maker. So this will allow us to set up a session and so on, right? Now this part is more or less standard, right? So you don't need to understand too much about it, but if you want, I can explain that. That means what we do is there are some classes which are already created in SQL alchemy. I have to import those classes, and then I have to declare a base class. And then what happens is, when I am declaring something like household survey, which is my own table which would be mapped to a class, I will actually inherit from that base class, right? So that I will take all the properties of the base class, and then I can add certain new things. So a base class is created using SQL alchemy's declarative base, that the basic class, and base is the parent class for all ORM map tables. That means this base that I am creating over here, this is declarative base. That means I am declaring this as the base based on the structure of SQL alchemy, how it has done that. And then base is the parent class for all ORM map tables, and every table class must inherit from base. So that means any tables that you create will be inheriting from this base class. So already we have learned the concept of inheritance in object-oriented programming. That means all the properties, methods, attributes, methods that are there in base class is available for my table, right? My table is household survey. So I will create, and then once I do that, then I have to create that instances for every row of the table. So this is the class that I am creating, class household survey base. So if you go back to the object-oriented programming, lecture, you will see how a class is created, how are the attributes created, how are the functions created, how are the constructors created. So same way we are creating the class which is household survey, and we are inheriting from the base class. So this is the standard notation or format in which we define a class in Python. So this underscore table name, a double underscore table name underscore equal to household survey. Basically what we are doing is this table name attribute defines the name of the table in the database. So this is again fixed, right? And then the columns, because we are already installing the column class, the column ID, household ID, number of people, household income, housing type are defined as class attributes using SQL alchemy's column class. So that is what is being defined. So you can see that we are defining that it is an integer, that it's a primary key, auto increment. So all the different attributes are given for this ID, household ID, all this value, and these are all following the the column class structure, the attribute structure of that, right? Then coming to this def underscore repar underscore self, this defining this is called define object, this object representation. This part is optional, but this is mostly oriented of how your data set, how your column self.household ID, the self.number of people, how they would be displayed in the screen or when you are printing them. To make sure that happens properly, then this mapping is done over here, where household survey, within household survey, household ID is self.household ID, household income is self.household income, and so on. But this is optional. If you don't do it, still it will work, but if you do this, the displays and all will be proper and organized. Now database underscore URL is equal to SQLite / household survey.db. This is where what we are doing is we are creating the and then engine equal to create engine database URL. So it is create engine command is used to create used to connect to a database, right? So that's the command which we usually give to connect database in SQL Alchemy, and this the URL is given, which is SQLite this / household survey.db. It is basically, it creates a database, but this database could be, this is a SQLite database, but otherwise we can also create a MSQL database or a PostgreSQL database. But we have to specify the proper string or that particular location where it is located. So MySQL : / we have to give all the different data as a string in this particular in this URL value, and then we are set to access the database. Then once we have done that, so what we do is we are creating the table. How we are doing that? That is, we do that the base.metadata.create all within bracket engine command. This command creates the table in the database based on the class definition household survey, because we have already defined that earlier. So that means we have already created the engine and the database URL already has been given. So based on that, we are already creating that particular table, and the metadata is, we are using the term metadata, means using the structure that is defined earlier, we are creating the table, and we are also starting this session maker bind equal to to this particular engine. This actually what it does is, then whenever this whenever we are creating a session, then this particular, we are binding this particular session with this particular connection that we have established, and we are connecting it with the database. So everything that will happen within this time, within the comments within this particular session, that will be going to this particular database. So session equal to session, this is a command that we have to give, and then we are storing the household data like earlier, that household survey, the format becomes a little bit different, and we are putting the values of each of this ID and all these things, and for different rows, and then using this command session.add all household data. This again we are passing household data to this. Automatically this values would be put into that particular table which we have already mapped earlier, right, to that particular this base.metadata create all engine command, right. So once we have done and automatically the data will be added to that particular table, and then we can commit the session, session.commit. That means for this particular session we are saving everything, and then we can this particular then we can print the data, of course, and then what we can do is we can also write a query, session.query, and that is household survey all. That means all the data will be retrieved. Instead of putting select star from this entire table, I am saying .all. That means all the results would be retrieved. So it retrieves all records from the household survey table. Result is a list of household survey objects which can be iterated over and printed. So that means this data would be saved in results, and this results could be again printed one at a time using a loop, and then we can close the session. Once you close the session, that means we are done with this particular connection, and then we can, this thing is over. Now what is happening over here is results is basically this instances, that means of household survey objects which are created, and then we can directly store the data which is retrieved from the database into that, and then we can print it. Now this create all statement, that is over here, this statement creates tables, and session maker configures the database sessions, and session opens a session to run queries. So this is the clarity. That means create all creates the tables, session equal to session maker bind engine. That means session maker configures the database session, that is, it is connecting to this particular table, and session opens a session to run the queries. So it is like sort of a cursor, right. So that is all run over here, and we can any kind of queries we can run. So this one function we have given, but there are other functions which you can call, and that could be and we can execute those functions to do different insert, deleting, and other kinds of things. So, add all already is insert, so update and other things could be done. So, SQLite, the database will be, so here we have created SQLite database, but we can also do it with MySQL or PostgRE SQL as well. And but we have to change the URL name so that we can actually connect with the right database, and then we can execute our commands. So, these are some of the references that we have utilized. To conclude, Python connects seamlessly to enterprise-grade databases using connectors and ORM frameworks, enabling scalable, secure, and maintainable data pipelines for real-world urban informatics applications. Thank you.